About analysis of variance. In short, we call it ANOVA. We have one-way ANOVA, we have two-way ANOVA, but this video I'm going to talk about only ANOVA. So on ANOVA, when we start testing hypotheses, we start with one population mean. So if we have a data set, it can be score, it can be anything. A data set, it has like 9, 6, 5, 7, only one population we are talking about. So what are the test options? So in this case, our test option is going to come off as if the data set is normal, large, and population standard deviation is known, then we have a z-test. Again, we have a formula for that, so we have a z-test. We have done that actually. Okay, so these are the conditions satisfied. Then we take the z-test and we go to the z-table, and then we have another option actually. If the data set is normal, population standard deviation is not known, then we have a t-test. So these are the condition when you have one population mean. Next, we're going to move into two population mean. So let's move into two population mean now. So now we have not only one group, we have two groups. So if we have a two group or two data sets, then what are the options? So option A in this case is going to be if the data set is independent, samples, normal population, large sample, and equal population standard deviations, then we can have a full t-test. If we have a two group, we can have a full t-test. Now we have another option, which is if the data set is independent samples and normal population, large sample, then we have a non-full t-test. Usually we do full t-test actually. Okay, so these are the options when you have a two independent population mean, two group we talk about. We have a formula for that actually. Okay, so and we do t statistics. We take the test statistics, which is t, and we have a t formula table also. So this time we don't do z-test, we do t-test. Okay, so when you have more than one sample, we go to the t-test. So let's move into three population mean. So in three population mean, if you have a three or more group, then we are going to talk about new test. We cannot do the z-test here, we cannot do the t-test. Then we come up with new test, which is if the data set is independent samples, these are the assumption, normal population, equal population standard deviation, then we can have a f-test, which is analysis of variance. Now we're going to analyze the variance. So let's have everything at the same time. Okay, so one population mean, as you see everything at the same time here, we have one data set, we use z-test or t-test based on the assumption, and when you have more than one group, one data set, we use t-test. It can be full t-test or non-full t-test. When you have a three or more population means, then we do f-test, which is ANOVA. So let's talk about ANOVA now. Now we have some kind of intuition that when you have three categories or three population, three independent samples, then we can do z-test, we can do t-test, and we do the f-test. That is the basis for f-test. Now we can say in analysis of variance that it is a method of testing. It is a method of testing the equality of three or more population means by analyzing sample variance. Also we can say a treatment factor is a property or characteristic that allows us to distinguish the different population from one another. So finally, we can say that f-test for three or more variable. So just in short here, if we have for x, y, and z, and this is 2, 3, 4, and this is 1, 2, and this is the two group, we are not going to use ANOVA. But as long as we use three or more group, so 5, 6, 7, this is one factor. This is one factor. This is not three factors. Three categories down here, but it's only one factor. So in this case, we're using f-test. And also, when we use f-test, the graph looks like that. So f-test, usually, the p-value down here, and if p-value is bigger, the more likely we keep the null hypothesis. If p-value is greater, then of course we don't keep the null hypothesis. In other words, if we see that p-value or probability value we get, which is less than significant level given, then of course we are going to reject the null hypothesis. If p-value comes out to be higher than significant level, which is going to be on the left, so we're going to keep the null hypothesis. And next video, we're going to talk about the formulas actually. So, and then of course the following video will have the full hypothesis for one-way analysis of variance with Excel and step-by-step calculation. Thank you.